Welcome you all. We are now discussing the synthesis of mechanism. In a four-bar mechanism, we analyze kinematic analysis and kinematic synthesis. So last session we have concluded these kind of things. If just we find the Freudenstein equation, for four-bar mechanism. This equation is used to find out the length of the various link of the mechanism for the three different positions. Just you recall the equation first. K1 cos pi minus K2 cos theta plus K3 equal to cos of theta minus phi. What is K1 and K1 equal to d by a, K2 equal to d by c, and K3 equal to a square b square c square d square divided by 2ac. So regarding this, we have seen one problem. Saw one problem last video. Design a four-bar mechanism to coordinate the input and output angles as follows. So just we are using the Freudenstein equation and for three different positions. So finally we find out the result of the designed mechanism of the various links, crank and coupler and so on. Today we are going to discuss about the mechanism, another one problem, solved problems on synthesis of mechanism. Synthesis a four-bar linkage problem. Synthesize a four-bar linkage as shown in figure using Freudenstein's equation to satisfy one of its positions. The specification of position of theta, velocity omega, the specification of position theta, velocity omega and acceleration alpha are as theta equal to 60 degree and corresponding omega 2 equal to 5 radian per second, and then pi equal to 90 degree and alpha 2 equal to 2 radian per second square, omega 4 2 radian per second, corresponding alpha 4 equal to 7 radian per second. Here omega is the angular velocity, the unit is radian per second. Alpha is the angular acceleration, the unit is radian per second square. Now you see the four-bar mechanism. This is the crank. Number 2 link is crank, 3 is coupler, and 4 link is output link. Here the input angular velocity alpha 2, the corresponding input angular velocity is omega 2 and corresponding angular acceleration is alpha 2, as well as for output angular velocity omega 4 and corresponding angular acceleration is alpha 4. So just we want synthesize this mechanism. So first of all you write down the given data first. AB equal to input link, that is called A. BC equal to coupler BC, and CD equal to output link C. Here is the output link C, and AD is a fixed link frame. Now you redraw the diagram as our convenient manner. Input angle is 60 degree and output angle is 90 degree, which means theta equal to 60 degree and pi equal to 90 degree. Now you see the A is the crank and B is the coupler, C is the output link, D is fixed link, D is called fixed link. You just to see here our angular velocity of the crank is omega 2, angular acceleration of the crank is alpha 2. So radian per second square. The corresponding output angular velocity omega 4 and corresponding angular acceleration alpha 4. So now we want to find out the link length A, B, C, D. Now we are using the Freudenstein equation. The equation is K1 cos pi minus K2 cos theta plus K3 equal to cos of theta minus 5. The equation number is 1. As you know, K1 cos pi minus K2 cos theta plus K3 equal to cos of theta minus 5. Here theta and pi. So what is K1? K1 is the ratio of D by A, and K2 equal to ratio of D by C, and K3 equal to A square B square minus B square plus C square plus D square divided by 2ac. And substituting the values of theta and pi in equation 1. So substitute the corresponding 90 degree and 60 degree in the Prudenstine equation. We got k1 cos 90 degree equal to minus k2 cos 60 degree plus k3 equal to cos of 60 degree minus 90 degree. Here cos 90 degree equal to 0, so k1 equal to k1 into 0 minus k2 into cos 60 degree 1 by 2, that is 0.5. So like this we got the minus of 0.5 k2 plus k3 equal to 0.866. This is equation number 2. Then differentiating the equation with respect to time, k1, just we differentiate the equation 1. Equation 1 is the Freudenstein equation, k1. So k1, just put out constant separately, and minus cos pi, differentiate cos pi with respect to pi, we got minus sin pi, and pi with respect to t, the differentiation of pi with respect to dt, minus of k2 into sin theta. Just we differentiate the cos theta, differentiate minus sin theta and d theta by dt. So in our right hand side, cos of theta minus phi, differentiate sin of theta minus phi, and theta minus pi separately we differentiation of theta minus phi divided by dt. Now k1 sin pi omega 4, k1, just rearrange the equation, k1 sin pi omega 4, because differentiation of pi with respect to dt is known as omega 4, and differentiation of theta with respect to dt, the time equal to omega 2. So pi differentiate we obtain omega, and theta differentiate we obtain omega 2. Here rearrange the equation, minus k1 into sin pi omega 4 plus k2 into sin theta of omega 2. Just we got in this minus sin theta minus pi into omega 2 minus omega 4. So finally put the corresponding values for these theta and pi. So theta equal to 90, pi equal to 90 degree and theta equal to 60 degree. K1 into sin 90 degree into 2 plus K2 into sin 60 degree into 5 equal to sin of 60 minus 90 degree. Again 5 minus 2, which means theta minus pi, theta minus phi. So we obtain the minus 2k1 plus 5 by root 3 divided by 2 into k2 equal to 3 by 2, or k1 equal to 2.165 into k2 minus of 0.75. So this is known as equation number 4. Again, now differentiating equation 3 with respect to minus of k1, differentiating the equation 3, as you know the equation 3 is this is. So differentiating equation 3 with respect to time, just you put out minus sin k1 is constant, and differentiate sin pi into differentiation of omega 4 divided by dt plus omega 4 into cos pi into differentiation pi with respect to dt, again plus k2 into sin theta into d omega 2 divided by dt plus omega 2 into cos theta into dt by dt. As your convenient, for your convenience, you should work out this, then you will get easily understood. Minus, that is equal to minus of sin theta minus 5, differentiation of omega 2 minus omega 4 divided by dt plus omega 2 minus omega 4. So cos of theta minus pi multiply with the differentiation of theta minus phi with the dt. Just you work out these things, then you will clearly understood. So k1 into sin pi into alpha 4 plus omega square divided by 4 cos pi plus k2 into sin theta into alpha 2 plus omega 2 cos theta. So you work out all these things, we got minus k1 into sin of 90 degree into 7. Just you put k1 equal k1 sin of pi equal to 90 degree and alpha 4 equal to 7, and omega 4 omega square equal to 2 square, cos pi equal to 90 degree. Just you put all corresponding values. We got minus k1 into 7 plus 0 plus k2 into minus into 1.732 plus 12.5 equal to minus 2.5 plus 7.794. So just you see, minus 7 k1 plus 14.232 k2 equal to minus 10.294. So rearrange the equation from this k1 equal to 2.033 k2 plus 1.47, equation number 5. From equation 4 and 5, from previous equations 4 and 5, we got 2.165 k2 minus 0.75 equal to 2.033 k2 plus 1.47, or k2 equal to 16.8. We obtain k2 equal to 16.8. From equation 5, k1 equal to 2.615 into k2. So we put k2 here. We obtain the value of k1 equal to 35.6. Now from equation 2, k3 equal to 0.5 k2 plus 0.866. Put all the k2 value. We got 9.266 for k3. Assume the length of the one unit for link A equal to 1. The crank length initially we assume 1, and we get the length of the other links. We know that k1 equal to d by A, that is formula. Put A equal to 1 here. We obtain D equal to k1 into, that is 35.76 units. So k2 equal to d by C, or C equal to d by k2. We obtain C equal to 2.12 units. Like this, k3 equal to a square minus b square plus c square d square divided by 2ac. Just we apply this, and corresponding value for a, b, c, we obtain the value of b equal to b square equal to 12.1272.854 minus 9.266 into 4.24, that is the value of 1233.56. So taking the root of this one, we obtain 35.12 units. So finally our result is corresponding A, B, C link length is, we write down